Wood fibers have been the main source for papermaking since the mid-1800s, when we abandoned rags as a raw material. Today we see new raw materials coming to the market, such as straw, bagasse, and bamboo. And microfibrillated cellulose is a new innovative component that can create something totally novel, although wooden fibers still have a very strong position. In this session, we have gathered companies with valuable experiences and ideas on how to take care of natural resources and convert them into valuable products. Our first presenter here wasn't the first to make paper from straw. The ancient Egyptians already made papyrus. But Columbia Pulp saw an environmental problem in their neighborhood and managed to turn it into a sustainable product. Let's hear the story from Columbia Pulp CEO, John Begley.
Good morning. My name is John Begley, and I'm the president of Columbia Pulp. Columbia Pulp is a manufacturer of wheat straw pulp located in eastern Washington. The background for Columbia Pulp is that over 20 years ago, the state of Washington was forced with an environmental problem that they needed to address. Wheat straw burning in Washington represented more air pollution than the top 20 manufacturers, industrial sites in the state at that time. So over 20 years ago, the state of Washington Department of Ecology looked at trying to find alternative uses for this straw rather than to burn it. The state started to fund different alternatives to look at creating commercialization opportunities for the straw. One of those was with the University of Washington Pulp and Paper School, looking at making pulp out of the straw. Now this is something that's been done for a long time, many centuries, dating back to the Egyptians and papyrus, using straw to make paper. Historically, when straw is a much weaker fiber than, for example, wood, and when you would treat it similarly to how you treated wood, you would destroy the fiber. So a new technique needed to be developed that allowed for a gentler process that didn't destroy the cellulose, and B, found a way of capturing the byproduct, the lignin carbohydrates part of the straw that wasn't going into the cellulose pulp. This technology that was developed will consume 250,000 tons of residual wheat straw every year and turn it into a commercial product. One of the reasons why we chose the location in eastern Washington was it was the center of one of the largest, densest wheat growing areas in the world. We'll consume about 250,000 tons of straw a year. Within the 75-mile radius of the mill, there is grown annually about 4 million tons of straw. Looking at adding Columbia Pulp fiber to your product mix, we have tested Columbia Pulp's fiber in various end-use markets. One of those is tissue, and found good success in substituting hardwood fiber for the Columbia Pulp straw. Adding Columbia Pulp fiber to your products can help reduce your carbon footprint. It's a utilization of an agricultural residual product. It's energy efficient. It has minimal water usage. We use about a quarter of the water that a normal pulping process utilizes. It's low odor. There's no sulfur involved in our process, so it's a sulfur-free process. It is unbleached and totally chlorine-free. It is a state-of-the-art facility with a state-of-the-art process. Thank you, and have a good day.
John Begley from Columbia Pulp. Now, from wheat straw in the US to this. Sugar canes like these are not only for making candy. Next up, Mr. Pawan Agrawal from Lange Group, who took the time to meet us recently to share his experience with pulp based on bagasse, the residue that remains after sugarcane stalks are crushed and their sweet juice extracted.
Describe your facilities and experience from pulp mill and pulp manufacturing.
Okay, you see, Lange Group is producing paper from agricultural residue, mainly bagasse and wheat straw, since 1998. So it's been almost 22 years that we have been producing paper from this very non-conventional type of raw material, agricultural residue.
Why have you chosen to use bagasse as raw material to your pulp mill?
You see, bagasse is I would say it has got some wonderful characteristics. It is, first of all, it is a very clean fiber, and it directly comes from the sugar mills. So it contains a certain percentage of molasses which we wash out during the wet washing process. And then it needs very gentle treatment. The caustic consumption in case of bagasse is pretty low. The overall lignin content in bagasse is low. And then the bleachability of bagasse is very good. And the silica content in bagasse is very, very low. So when we see the paper properties, we find, except for a slight issue of opacity, all other properties are quite comparable to a paper made of wood pulp. So Bagas we find to be a very good fiber for making bleach grades of pulps, and also unbleached, what we have made in the past, those also have been of really very good quality.
In your experience, what are the specific characteristics and strength of bagasse as raw material for paper making?
Okay, I told in my earlier reply also that bagasse is a very good fiber to make bleach grades of paper. Number one, if treated properly, if fines are taken out properly, if depithing is done, dry depithing, moist depithing, and wet washing is done properly, then we get very good fiber from bagasse. So the biggest advantage of bagasse is its bleachability. Number two, it doesn't have any specky material. It doesn't give any specks at all in the paper. The paper sheet is very uniform and clean, a clear paper sheet. So Bhagas has got good strength, a very decent strength. The only drawback, if I can say so, in terms of properties with Bhagas is we get slightly lower bulk of paper with Bhagas, number one, and number two, the opacity of the sheet is slightly on the lower side. So we take care of these limitations by our fillers and some long fiber that we add to the furnish, and then it runs beautifully.
What are the challenges and opportunities from using bagasse?
To produce high bulk paper with bagasse is a challenge, and we have developed our own means to overcome this challenge. But otherwise, I really don't find any issue in running bagasse.
Is your usage of bagasse a strength in marketing of your consumer products using marketing arguments such as sustainability?
Of course. Bagasse we market our raw material as environment friendly, and in India today the agricultural waste has become a big problem in the sense that it is being burned by the farmers at many places and creating a lot of air pollution. So if we won't be using bagasse to make paper, the alternate uses are quite limited. So in a way, we are converting this waste of sugar mills into paper. I would say bagasse is a very good substitute of wood fiber. It's a very good substitute if handled properly. Okay, thank you.
Pawan Agrawal, Managing Director at Lange Group. You are interested to know more about this, don't forget to sign up for the dive session on this topic for next week. From the US and India and new materials to Sweden and wood fiber. Our next speaker represents a company with its production only about an hour away from this studio here in Karlstad, Sweden. Founded in the late 19th century, Rottneros has over 125 years of experience with pulp and paper manufacturing. With us today is Jens Hallendorf, giving us an introduction to what high-yield pulp can do for tissue making. Welcome to Tissue Talks, Jens.
Thank you very much, and hello everybody. During the days when you were supposed to have been here as well, we from Rottneros had planned to invite you all to visit us at the mill. Since this is currently not possible, I would like to invite you all to join me on a digital journey. We take a quick flight 60 kilometers north from Karlstad and land in the midst of the reason why Rottneros is situated where it is, the forest. The forest and proximity to water being necessities for both pulp and paper production. In the surroundings of Rottneros, the absolute majority of the growing forest is softwood based. And with the forest coverage we have in the county of Värmland, naturally also follows a large number of sawmills in our neighborhood. The availability of sustainably grown and harvested raw material with possibility to selection of wood species and age of wood provides us with the possibility to select the most suitable fiber raw material to match the process in order to achieve required pulp properties. This being the background to why Rottneros have targeted to have what we believe is the widest portfolio of high-yield pulps in the market, and also thereby being able to supply the majority of end-use areas within the paper-making world, where naturally our major customer areas are board and tissue. Rottneros mill have two separate non-integrated production lines, one softwood BCTMP line fed with chips, and one rather unique stone groundwood line fed with spruce roundwood. On our woodyard, we separate roundwood and chips, and additionally we store the chips separated based upon species and age. This can sound unnecessarily complicated, but based upon the final property requirements, we blend wood chips with different fiber properties to match the requirements of the final product. Rottneros Mill recently finalized a substantial reinvestment program, which was targeting to reduce the environmental impact through reduced dependency on fossil fuels, reduced emissions to air and water, and with the bonus effect of increased installed capacity. The mechanical pulp mill, in comparison with the kraft pulp mill, adds higher level of freedom in regards of fine-tuning the final properties beyond what the inherent fiber properties gives. Through combinations of chemical pretreatment and high and low consistency refining, this gives us the versatility in combination with raw material impact to create adapted qualities dependent on customer requirements. Our two different production techniques both aim to defibrillate chips down to separate fibers suitable for paper making. They are both using mechanical processing as the major component, but the final outcome in finished products are from a fiber scale perspective significantly different. From both lines, we produce products dedicated and well appreciated by tissue producers. Together with Valmet at the pilot machine, we have run a pilot trial program to look at how the impact of high-yield pulp addition at different levels influence final paper properties. Also, the impact of separate versus co-refining of high-yield pulp and kraft pulp have been compared. And last but not least, how does tissue-dedicated high-yield pulps with significant difference in average fiber length influence some sought-after final properties? I hope you will find the results from the pilot trial being of interest for you, and I will in the deep dive present the outcome of what the trials have given in terms of tissue-relevant final properties, and more in detail present the fiber property difference in the high-yield pulps included in the study. And thereby, I would like to conclude by hoping to see you all at the deep dive. Thank you very much.
Thanks, Jens. I was curious, how widely used is mechanical pulp?
We believe it could be utilized more, but there is one downside with the mechanical pulp, and that is that it loses brightness, and thereby the paper becomes less white. However, like my colleagues presenting straw and bagasse, I believe that we will see customer-driven demand towards more sustainable solutions. And the mechanical process as such utilizes more than 95% of the wood raw material and thereby have a low yield loss, which I believe is going to be certainly a positive effect on the sustainability question.
Thank you very much. This has been really interesting. Thanks for today. Now, the goal of our next speaker is to bring the next great opportunity to the paper industry. And by working with a team of Valmet experts and researchers in collaboration with University of Maine, his vision has a good chance of becoming reality. David Cowles is the right person to guide us through what microfibrillated cellulose is and the many different ways that this can be used.
What is MFC? MFC is microfibrillated cellulose. It falls within the general umbrella of a whole host of different nanocellulosic materials. As you can see from the graph, our MFC falls into the fibril range. What does that mean? Well, it's not all the way to the cellular level, obviously, of cellulose, and it's a far cry from a tree. What do we mean by MFC? And we typically measure it as a percent of total fines. What is a fine, you may ask? A fine we define as a fiber that is less than 0.2 millimeters in length. So we might have processed a product of MFC that might be 80% fines. That means that 80% of that sample is less than 0.2 millimeters. What are the benefits of MFC? First off, MFC is a sustainable resource that's derived from trees. This has wonderful possibilities for sustainability. For example, in Brazil, a tree farm made of eucalyptus might have a full tree growth of somewhere between 6 and 8 years before it's harvested. That tree root can then be used 2 or 3 more times, or 2 or 3 times total, for possibly 20-some years when the same tree root before the plant is dug up and the site is allowed to rest. That could be 3 harvest crops. That is basically the definition of sustainable resourcing there, and makes it a very efficient process to possibly use and do work with MFC. Secondly, the flexibility of production. The Valmet way is purely a mechanical process. However, there are many other people that are experimenting with different ways to get cellulosic nanomaterials. Some of them involve some exotic chemistry and reactions. Some are a combination between chemistry and mechanical process. We do view that pure mechanical fiber is very much of a superior fiber that imparts a great deal of strength and value for the customer. Speaking of value, what is the value of MFC to the paper maker? There are many different ways that the paper maker can derive value from MFC. Strengthening of the sheet, might be fiber substitution, possibly adding more ash, possibly using it as to enhance barrier properties of specialty packaging. We feel that MFC has certainly a place as a building block towards getting rid of a lot of plastic and packaging, and provides a lot of value and potential for specialty paper marketeers. So it depends upon what each company and process wants to do with MFC, but MFC provides the paper maker with a toolbox of possibilities that only their imagination can rein in. Next, most people want to know is what markets is MFC in? So as you can see, people are constantly searching for new ways to use nanocellulose materials. Valmet is concentrating on using it in paper and packaging, but there's still a whole host of other innovations that are being done and explored, and will continue to be done and explored for the years to come. At this point, I'd like to thank you for your time, and I would like to invite you to join me in July for a deep dive into how do we produce MFC and how would it benefit the tissue producer. I look forward to speaking with you and answering any questions that you may have at that time. And thank you again for your time today.
David Cowles, be sure to sign up for that dive session. Yes, we will get to those reflections in just a moment, but first I'd like to welcome on stage Ulf Jonsson, Concept Manager Mill Technology at Valmet. Hello, Ulf. What have you got there?
It's bamboo.
Oh, of course. Tell us about that.
Yeah, bamboo is also quite frequently used to produce tissue, especially in Asia. And the characteristics of a bamboo fiber is rather similar to that of hardwood and softwood. You could say it's like a compromise between the two of them. So it's really doable for producing facial and bathroom tissue.
Okay. And what about the environmental aspect?
Yeah, it's a fast-growing grass, so it's ready for harvesting in 1 to 5 years. It's a regional source, and so you can minimize transportation. It's a carbon sink can be used as, and it also emits more oxygen than the comparable tree.
Okay, that sounds good.
Yeah.
Now, we do have some reflections from the audience. I think you can put that down if you want to.
Yeah, it's easier.
Promising for our future that alternative fiber is an actual opportunity. Yeah, that's very true.
Yeah, I agree, and I see more tools in the papermaker's toolbox as an opportunity.
Yeah. More fiber alternatives mean more tools. Yeah, to play with as a papermaker. Somebody had really the same thought as you did.
Good.
Okay, let's see if we have some more. Promising. No, that was the same. Do we have another one? I think that you have another one. Do you have any thoughts of your own, Ulf, on the topic?
Yeah, as I said, the toolbox opens up, and you can see that going back to the non-wood is like going back in history, and now we are opening that again and exploring it and taking care of lost know-how, I think.
Yeah, that's about time.
Yeah.
Sounds good. So thank you very much for
thank you.
helping me out with this.
I bring it out.
Oh, yeah, thanks. The increasing tissue production in China and the latest on sustainability in the tissue industry. That's what's coming up next. But first, a 5-minute break.